So this session today is going to be about hypothesis testing. I know this is kind of a complicated procedure, and it's really easy to get lost in all of the different steps and things that you have to do. So we're going to look at a few different examples. We're going to do some things where we're calculating things by hand, and then we'll also do some stuff with StatCrunch where you can see how to get some of the information for the hypothesis test from StatCrunch. So we're just going to start with an example. So in this one, a poll in 2004 found that only 23% of American adults were in favor of abolishing the penny. And this says that the issue has come up again recently, and now some people are claiming that there's more support among Americans for abolishing the penny than there was in 2004. So a new poll was done, and out of 1,260 adults, 314 said they were in favor of abolishing the penny. So what we were going to do is use the new poll data to conduct a hypothesis test of this claim at the 0.05 significance level. So over on this side, I pulled up the document that has all the steps for the hypothesis test. And I did put this in your notes for this week. It's actually in the notes on the PowerPoint, but this file has it all kind of together. And this will be good for next week too, because it also talks about means and standard deviations, whereas this week we're just talking about proportions. So let's start by going through all that we need to do step one. So for step one, what you want to do is write down the actual claim. That kind of gives you an introduction to the hypothesis test in the first place, and then use that to write the alternative hypothesis and then the null hypothesis. So we're going to start by, just writing down the claim. We have, for step one, our claim is that there's more support now among Americans for abolishing the penny than there was in 2004. But we want to put this in very specific terms. So if we're saying that there is more than there was before there was 23%. So what we want to say is that now that more than 23% of Americans support abolishing the penny. So this way we have everything in very specific terms. We have our percentage that we're comparing this to, and we know how we're comparing it. So we want to say for our claim that it's more than 23%. And we also have exactly what we're talking about with our claim, how many Americans support abolishing the penny. And since this is a percentage, that automatically tells us that we're dealing with a hypothesis test about a proportion. So if you have something that's a percentage, that tells you you're dealing with a proportion hypothesis test. Okay, so what we want to know is what the parameter would be. Since it's a proportion, that means that we're talking about P. And then we want to know what the inequality is. This is where we're trying to think of our alternative hypothesis. Since this says more than, we want to make this a greater than. And then the number that we're using, we're comparing it to the 23%. So this is going to be 23%, but we're going to write it as a decimal. So this is our alternative hypothesis right there. To write our null hypothesis, all we have to do is replace this inequality with an equals sign. So there's our null hypothesis. And most of the time, if you're doing your homework in my stat lab, they ask for the null hypothesis first. But if you just go ahead and write this down, you can figure out the alternative hypothesis and then the null hypothesis. Okay, so that was all of step 1, is coming up with the claim and then those 2 hypotheses. So now we want to go on to step 2. And as this says in most of your homework problems, the significance level will be chosen for you. But you still need to have it written down. It's really important to have it written down so that you don't have to go back and search for it, because we do use it later on in step 4. Now, if we were trying to choose our significance level, we'd look at what it is that we're testing and see what the consequences would be if we made a type 1 error. So in this case, a type 1 error would be supporting the claim that more people are in favor of abolishing the penny when that's not really true. So if the proportion of people who want to abolish the penny is still only 23%, and we said it was more than that, that would be a type 1 error. So the consequences of that, you have to think a little bit creatively with these things. The consequences might be if we thought there were more than 23%, or if the support was going up for abolishing the penny, that might encourage people to start actually trying to get the penny abolished. Or it might have some effects on financial institutions. So it's kind of a subjective thing as how serious you think that would be. But a 0.05 significance level is kind of a standard one. So that one's perfectly fine. That's kind of between being not very serious and being very serious. So in this one, they already told us that our significance level is 0.05. So step 3, and this is to find the test statistic. And this is where you have to know what it was that you were looking at for your claim. So if we go back up here, in our hypotheses, the parameter we were dealing with was P, and we said this was a test about a proportion. So that tells us which one of these 3 formulas we need to use. And you can even just look at the formulas and pick out the one with the right letters in it. So where we had in our hypotheses, we had P, that means that we want to pick the formula here that has P's in it. So our formula, there's our formula that we want to use. And now this is one of the hardest things in hypothesis testing, is taking the formula and getting everything in the right place. So the way that these formulas are written on this handout, anything with a 0 after it, that's something that comes from your hypotheses. So where we have the P0 here and here and here, that number is the one that we used in our null and our alternative hypothesis. So that's going to be the 0.23. Same with that one and that one. Then anything that doesn't have a 0 has to come from your sample data. So the P hat is the sample proportion. And if they gave you a percentage or a proportion in the problem, then you already have that. Otherwise, you have to calculate it. So it would be the number of successes over the number of trials. And in this problem, they didn't give us a percentage. They just gave us how many said they were in favor of it and how many were in the survey altogether. So this is one where we do have to calculate our P hat. Okay, so this comes out to be 0.249. Okay, so we have that to put in here, and then the N that we'll put in is the 1,260. That's how many people took the survey. And when you're doing this, go ahead and write down, even though it looks like it might not be important, go ahead and write down the letter that's on this side of the formula, because that's going to tell you later which distribution function to use. So this P hat is the 0.249. The P0 is the 0.23. And then down here we have the 0.249 and the 1 minus, that is the 0.23. And this is 1 minus 0.23. And that's the 1260. Okay, and if you're going to try and do this all in one step on your calculator, you have to be really careful. If you're going to do it in one step, you have to put this top part in parentheses. All of that into my calculator. And that gives me a test statistic of 1.60. For step 4, we're doing this using p-values. So now what we're trying to figure out is what's the probability of getting a test statistic more extreme than this. So to do this step 4, first we want to go back and look at our alternative hypothesis to tell whether we have a left-tailed or a right-tailed or a two-tailed test. And in this one, our alternative hypothesis had a greater than. Since this is pointing to the right, that means that we have a right-tailed test. So when we draw our picture, we're going to be shading to the right of our test statistic. So here's our picture. Since this up here was a z, that means that what we're drawing the picture of is a standard normal distribution. Okay, I'm going to put my test statistic over here. So I'm just plotting my test statistic on the graph. And then since this is a right-tailed test, I'm shading from that test statistic to the right. To find my p-value, I want to find the area of this. Or in other words, the probability that z is 1.6 or greater. So to do that, I'm going to use my normal CDF function. I'm going to put in 1.6 for my lower bound, a big positive number for my upper bound, and then since this is a standard normal distribution, I'm using 0 for my mean and 1 for my standard deviation. So what I came up with was 0.0548. Since this is a probability, I'm rounding it to 4 decimal places. Some places in my stat lab, they only have you round it to 3 decimal places. Okay, so this is my p-value. So for part B of this step, this is where I'm going to take my p-value and go back and compare it to my alpha. So I'm down here on step B, or part B of step 4. And all you want to do is take your p-value that you just came up with and put that in here, and then put your alpha in over here. And I know this gets confusing with all the different p's. This p is the p-value that we just found up here. It's not the same as the p in our original hypothesis. So we're talking about 2 different p's. Okay, so if we want to take p and compare it to alpha, the p-value we just found was 0.0548. And the alpha that we had back up here was 0.05. So we just substituted those 2 numbers in there. Now we want to look at this and determine whether it's a true statement or not. And actually 0.0548 is a little larger than 0.05. So that means this statement is actually false. False means that we have a negative conclusion. Okay, so if it had come out true, then we'd have a positive conclusion. If it comes out to be false, then we have a negative conclusion. And the way we write that, and this is just in terms of our null hypothesis, so for a negative conclusion, that means we use the word not in there. So we would say either do not reject the null hypothesis, or another way that they say it sometimes in my stat lab is they also will say fail to reject the null hypothesis. Either one of these is fine. Both of them are talking about a negative thing. Either we're not rejecting the null hypothesis either way. Okay, so then for our last step, we're just going to take this conclusion and put it in terms of our original claim. So for this one, we actually want to go back to what our original claim was back here. So this was our claim. We're going to rewrite this claim and include the conclusion that we came to. And since we had a negative conclusion, that means that we didn't find sufficient evidence to support our claim. So here's where, I know this seems like a lot of writing. You just write something like this. We'd say there's not sufficient evidence to support the claim. And then you just totally restate your claim. That's why we were kind of careful about how we wrote it out in the first place. So here you're just rewriting what the original claim was. Okay, so in other words, we didn't find, even though we had some survey results where the proportion was a little bit higher than it had been when it was 23%, it wasn't enough higher to give us sufficient evidence to support the claim. Let's look at this on StatCrunch now. So if you're going to do a hypothesis test on StatCrunch, you still have to do a lot of the initial work. So to do this on StatCrunch, we'd still have to have basically the first two steps done, because we have to know what our null and alternative hypotheses are. And we have to know what our significance level is. So to do this one on StatCrunch, since we don't have the original data, we just have some summary values. We're going to do stat and proportion stats. This is for just one sample, and we don't have the original data, so we're going to say with summary. So here's where it's going to ask us for some of the numbers. So number of successes is the same as our X down here. So we're going to put in 314. The number of observations is the same as our sample size, or the number of trials. So that's 1,260. And here's why we already have to have our null and alternative hypotheses figured out, because this asks us what they are. So we want to put in, for the H0, we want to put in a P of 0.23. And then on StatCrunch, they have HA instead of H1 for the alternative hypothesis. So we just need to put in the right inequality. So this was a greater than. And then that's all we have to do for this. And this will calculate our sample proportion, it will calculate our test statistic, and it will calculate our p-value. So we can even just use this to test to make sure that we came out with something close to the right values. So here we had our sample proportion was 0.249, and they didn't round it quite as much as I did. So their test statistic is here where it says Z-stat. That's a little bit different than what mine was. That's probably just because of rounding error, because I did round this one a little bit. And then the p-value that we came up with was 0.548. Theirs was 0.0548. Theirs was 0.0526. So again, a little bit of difference, just probably because of the rounding error, because our test statistics were a little bit different. But the main point of this is that this is all that StatCrunch will give you. It won't tell you what the conclusion was, because notice it never asks you what your significance level is. So it just does the calculations for you, and then you have to go on and do the second part of step 4 and also step 5, where you're figuring out your conclusions. So from here you would go and compare your p-value to your alpha. In this one still we'd come up with a negative conclusion, so that means that we do not reject the null hypothesis and there's not sufficient evidence to support the claim. So what StatCrunch will do for you is basically step 3 and step 4a. You have to do the rest of the work. We've got a survey, and out of that survey, 297 out of 400 union members favored the Republican candidate for governor. Based on this, a newspaper article said that union support for the Republican candidate is over 70%. So what we want to do is test the claim and see if the newspaper really should be able to write that, or if there's sufficient evidence to be able to state that. So for step 1, we're going to start by writing down our claim, and you can kind of paraphrase what they say. You could just say union support for the Republican candidate is over 70%, or you could say something like more than 70% of union members favor the Republican candidate. It doesn't really matter which way you write it, as long as you're sure to get the numbers in there, and also something that tells you about what the inequality is going to be, and then a basic explanation of what it is that you're talking about. Okay, so from this we want to write our alternative hypothesis. So since we've got a percentage here, that tells us we're talking about a proportion. So that means that our parameter is p. Then since it says more than here, more than means greater than. And our number is 70%. We're going to convert that to a decimal, so that's just going to be 0.7. Okay, and then our null hypothesis is that p is equal to 0.7. So there's step 1. For step 2, this told us to test it at the 0.05 significance level, so our alpha is 0.05. For step 3, I'm going to go back to this handout. If we didn't already know that this was talking about a proportion, the key is we already actually figured that out, because we figured that out in our null and alternative hypothesis that the parameter was P. So again, that kind of lets us pick out the right formula from these three. So I'm writing down the formula that we're going to use for the test statistic. And then we have to figure out the right numbers to put in the right places for this. So the p-hat is from our sample data. And again, on this one, they didn't give us a percentage or a proportion. They just gave us the number that did favor the governor and the total number in the sample. So this is our p-hat, is the number of successes over the number, or over the total that were surveyed. The p0 is the number that we used in our hypotheses, so that's 0.7. So down here we have the 0.7, 1 minus 0.7, and our n is the same as it was here, so it's 400. Okay, so then we would plug that into our calculator. Okay, so I'm getting 1.855. That's it for my step 3. For my step 4, I'm going to look at what kind of test this is. On this one, again, since our alternative hypothesis points to the right, that means that this is a right-tailed test. So when I draw my picture, and this is, again, the standard normal distribution, since this is a z, so I'm putting a 0 here. My test statistic is going to go over here in the picture. Since it's a right-tailed test, I'm shading from there to the right. So in my calculator, I'm going to do normal CDF. I'm putting in 1.855 for my lower bound, big number for my upper bound, and 0 and 1 for my mean and standard deviation. Okay, and from that I get 0.0318. So this is my p-value. Okay, for step 5, oops, not step 5 yet, sorry, step 4b, I'm going to compare my p-value to my alpha. So I'm going to use this inequality. I'm going to put my p-value here and my alpha on the other side. My alpha was 0.05. Okay, for this one, when I look at this statement, this is actually true because 0.0318 is less than 0.05. So that means I'm going to have positive conclusions. So my positive conclusion in terms of my null hypothesis is that I do reject the null hypothesis. Instead of do not for a negative conclusion, for a positive conclusion, it's do reject the null hypothesis. And a lot of times you just see this written as reject H naught. Okay, then for my step 5, I'm going to take this and write it in terms of my original claim. Since this is a positive conclusion, I'd say there is sufficient evidence to support the claim that and then I'm just going to go back up here and see what my claim was to start with. I'm just going to rewrite this just like it is. So support the claim that more than 70% of union members favor the Republican candidate. Okay, so if we look back at our original question, kind of the question was whether it was okay for the newspaper to say that, and our answer is yes, it is. There's sufficient evidence to support this statement. Okay, so if that's our claim, this is still a little bit vague because we have to think about what it means that there were more males than females. This is something you run into with hypothesis tests a lot, though. Sometimes it'll talk about something being a majority or just one thing being more than another. So what that usually means is more than 50%. So we could even amend this a little bit further. We could say more than 50% of drivers in car accidents were male. That way it makes it really specific. So from that, we could write an alternative hypothesis. So again, we're talking about a percentage, so that means it's a proportion. So we're going to use P for our parameter. We've got the more than means a greater than. 50%, we're going to write that as 0.5. And that means our null hypothesis is that P is equal to 0.5. Okay, so that was step one. Now for step two, in this one, since we're making up our own hypothesis test, we have to think about what the consequences of a type 1 error would be. So a type 1 error would be supporting this claim that the proportion is actually more than 50% when it really isn't. So consequences of that kind of error might be things like this kind of thing gets used by, say, car insurance companies. So they might charge higher rates for the males than they do for the females if they feel like male drivers are more likely to get into accidents. So if we're not really sure where to put this, we can just use a kind of a standard 0.05. So this isn't something that is maybe super serious that we need to go to a really small alpha, but it's not, you know, it might have some serious consequences. So we'll just go right in the middle. Okay, then for step three, now on this one, we could go ahead and calculate this by hand, but since we already have it in StatCrunch, we're just going to use StatCrunch to do step 3 and step 4. So we're doing proportion stats, one sample, and this time we have the data, so we're going to say with data. Okay, so what we're looking for is the gender. And since we're talking about males here, then we want to put down what our success is. And this is one place you have to be really careful with StatCrunch because it's very picky about this. You have to look at your data and see what it was that they used to signify a male. So, and you have to put exactly that in the success box. So our success is going to be if we have a capital M in the gender column. Okay, and then we're doing a hypothesis test. Our P actually is 0.5, and then for our inequality, we had a greater than. Okay, so now we can go back and, and put all this into our step 3. This would have been a Z0, so our test statistic is right here, is 88.42. Then for step 4, our p-value is, and all this tells us is that it's less than 0.0001, meaning it's very small. And if you think about this, if we were figuring out our p-value by hand, we'd have our picture here of our standard normal distribution. This test statistic of 88.42 is like way, way over here. So it's not surprising that the p-value is really small, because this is going to be a super small number. You could figure that out on your calculator, and it would probably give it to you in scientific notation because it's going to be so small. Okay, so then for step 4b, we're comparing our p-value to our alpha, and we just know this is less than 0.0001, so we could even put that in there. Okay, so is this true? Yes, it is. And then our conclusion is going to be a positive one. So we're going to have that we do reject the null hypothesis. For step 5, we're going to say there is sufficient evidence to support our original claim. Something like this: the percentage of male drivers was different than 50%. So if we're just saying, well, we don't know if it's 50% or not, we don't know whether it's more or less, then we can just say it's different. And the difference this makes is in your alternative hypothesis, this means that you have a two-tailed test. You have a not equal to. So instead of having a greater than or a less than, here you have a not equal to. Your null hypothesis is still with the point, with the equal sign. So if everything else is the same here, so if we're still using the same data, then all we would do with this is go back and change our inequality here to a not equal to. And if we recompute this, notice everything still looks the same. So our test statistic is still the same, and our p-value still looks the same. It just says that it's really small. But in actuality, for this, when you calculate your test statistic, because this was a not equal to, that means that we have a two-tailed test. So when you're doing step 4, it's a two-tailed test, and that means that we take our test statistic and plot it on our picture, so it's still going to be way over here. And then whichever side of 0 it's on, we find the area in that tail. So in this one, since it was to the right of 0, that means we're going to find the area in the right tail. But then because it's a two-tailed test, what that says is it could also be over in the left tail. So we're going to take this area and multiply it by 2. So our p-value is going to equal this area times 2. So if we were doing this on our calculator, we'd have normal CDF. We'd use this as our lower bound, big number as our upper bound and 0 and 1 for our mean and standard deviation. So we'll see what this actually comes out to be. Okay, I don't know if I've ever had this happen before. This on my calculator, it didn't even give it to me in scientific notation. It just said 0. In other words, it's so small that even the calculator isn't going to bother with how many decimal places it is. So if I did this on my calculator, it came out to be 0. Technically, we still have to take that times 2 to get our p-value. So we would take whatever this comes out to be times 2. In this case, 2 times 0 is still 0. But this is our p-value. That's just one of those things that's kind of confusing on two-tailed tests, is you have to find the area, whichever tail it's in, and then you have to multiply that area by 2 to get your actual p-value. But StatCrunch goes ahead and does that for you. If you tell it that your inequality is a not equal to, then it knows it's a two-tailed test, so it goes ahead and calculates that for you.